we're going to look at how we're going to place a circle in perspective or drawing ellipses in perspective. So what is usually happening is a little bit of discussion about the chicken and the egg here. What comes first? Does the square come first or does the circle come first? In our method, we believe that the circle comes first and the ellipse comes first, and I will explain you why we think this. So if we have a vertical wall and we want to place an ellipse on this, we could assume that this is a square. And if you know that this is a square, you could just go ahead and divide it in half and find your section lines that you want to be working with, and then see that you can place an ellipse in here. So if that's the case, what happens if you draw another line and you want to place an ellipse in here? The question now becomes, is this a square, is this a square, or is this a square? So I'm not sure where the square is any longer, as soon as I need to place multiple ellipses. So here's the question really, what is the square? And if you base the ellipse on a square, you need to be always able to draw a square. What we are thinking is that if you can place a circle into perspective, you should be at all times able to build a square around it. So this would be the tangencies that you're getting from it. And with this, you would have a square. So to determine this, we're thinking that initially we don't necessarily know the line at the end. It's because we need to define this square or the place where the circle needs to live in one way or another. So if we're looking at now the setup right here, what we have is we have a side view of this wall. And I've repeated this wall 3 times along here. You will see in the demo in a second why I repeated it a couple of times. But to look at this, the question becomes, if we determine the height here, that's how tall our circle is supposed to be, and we determined where it's going to start. So this is the starting point. Then there's only one option for a circle to fit into this. So this circle actually needs to meet the following condition. It needs to touch here at halfway point, and what's going to happen is there will be 2 points up and down that would perfectly are matching with one another where it's going to touch. So what I'm doing is I'm just taking now the circle guide and try to find the circle that fits into this for those conditions. So here we go. This looks pretty good. And I can place my circle in here. And with having this circle now, I can determine where this will become a square. So the conditions we have now, and if you check in the book we explained in page 73, is this point and this point, they are directly above one another. And then if we find the halfway point on the other side, this line goes directly into this direction and is parallel to the other lines here. So what you have is these lines are all pointing to the right vanishing point. And if we're going back into here, or if we're going into our perspective drawing, these lines are going to the right vanishing point. So the assumption is then that there's only one circle that fits into this area to make it a square and that meets these conditions. So the first condition we can find pretty easily and say, well, it should hit halfway point here. But before we do this, we need to actually look at something different. We need to look at the setup of the ellipse in general. So if you looked at the earlier chapters, we have the minor axis, and the minor axis for an ellipse needs always to point towards the vanishing point. Now, what is the vanishing point? The vanishing point in this case is it needs to be 90 degrees towards the wall it's going to be on. So if you want to think about it this way is you have a circular cutout and you take a push pin and you place it into the wall, and this is the push pin. This is the minor axis. You're just pushing the ellipse against the wall. Now the minor axis, I'm not sure if this specifically is the minor axis, but I know it's one of the minor axes going this direction. So at this point we can say we can start drawing the minor axis around this, or an ellipse around it. And what we need to make sure is that it meets all these conditions. So let's draw the first ellipse into this. And the first thing I'm going to make sure, oh yeah, it's the right direction with the minor axis. And we're drawing this ellipse in. What you see now is, let's see where it touches. It touches up here. It touches down here. It touches here. And when we put an end cap to this, it touches right here. So going back to this side and looking at the conditions we want to meet is, we want to meet half point. Not happening. Halfway is not happening. And then the other thing that's not happening is these 2 points are not above one another. So this is not a condition that's met either. And in addition to that, if we connect those 2 points in the back, they should actually point towards the right vanishing point. So all of these conditions are not happening. I just repeat again. The first thing that you need to do is make sure the minor axis of the ellipse is 90 degrees to the surface. If this is not met, then don't even bother checking the other things. So let's do this the whole thing again. I imagine there's somewhere sort of the minor axis this direction, and we're drawing an ellipse in here. So let's check what's happening here. So we build the end cap, and at this point it touches here, it touches here. So this is definitely not the halfway point either, so this is not the correct degree of ellipse either. And we're looking at where it touches here and here, 1 second, and those 2 points are not above one another either. So now they're actually facing the different direction and they're tilting slightly downwards. So we're not meeting these conditions either. So if you look at this, this was supposed to go to the right vanishing point. If we compare those two, that means this was really far off. This is much closer than what we wanted to get. So this was sort of the direction. And that's what you're going to be doing. You're going to adjust the ellipse to the degree you want to. Usually you would do it in one drawing. I do it in multiple drawings so we can actually see this, how it comes about. So let's do this. And this time I'm going to be more purposeful about this. I'm going to mark the halfway point. You don't need to actually put a dot in there. You can just aim for it. But sometimes it helps to just have that happening. Now I'm drawing the ellipse in here, lightly by hand, and I'm gonna now check if this is actually working out. So halfway point I met on this side. So on the end side here, on the other side, that looks okay too as a halfway point, and if I connect those two, they're pointing towards the right vanishing point, with all the other lines that we have already pointing to the right vanishing point. The next thing that I can then check is, well, it touches about here and touches here, so we're meeting that condition that they're vertically sitting over one another. At this point, my ellipse is still a little bit loose, so I will have to basically grab an ellipse guide and see which one fits the best to clean up this ellipse. So here I would have a 65-degree ellipse. You see that I'm aiming it towards the vanishing point, and I meet the top and the bottom, but the side points are not matching, so this is too large of a degree. Then I'm just going a little bit further down, and you see that I have the 50-degree ellipse here, and I'm placing this on here, going same way. I'm first making sure I'm going towards the vanishing point, to the left vanishing point with the minor axis. It's pointing out here. And now I see that this actually fits pretty well, so I can close this up. And as we talked about beforehand, at this point I do have drawn a square in perspective, because these bounding lines make a square. And this is really essential for us to measure things later on. So when we draw the aircraft or a car or any other object of your choice, you know this unit is 1 and this is 1. So if you want to have a division by 1 to 2, we can go in here and multiply this forward to end up at this point here. Drop the line downwards. And now we have in perspective the proportion of 1 unit here and 2 units here. Later on you can determine what it's going to be. You could say, well, this is 1 foot, 1 meter, whatever you want to do, but as soon as you place a human or something like that in there, now you know actually what size this truly is. So if that person would be 6 foot tall, I'm just taking them over, and that would be about 10 feet or something in that range. So this is how we talk about ellipses, and just make sure, I want to repeat this, minor axis is the most important thing. If it's not pointing to a vanishing point that is 90 degrees to the surface of this area, it's not going to work. Then after you have managed this, then you can actually check all the other conditions, and that would confirm that you actually drew an ellipse in the correct, with the correct degree into the correct direction.